All right, today is lesson 3.4, day 2, applications of abortion. It's basically rates. Here's the homework that goes along with it. Answers to last night's homework. All right, we are talking first about a rate. A ratio is a fraction that relates to numbers. A rate has a label, like cost per pound, miles per hour. That is a rate. Now, 1 gram of apple juice costs $1.56 for 48 ounces. Find the unit rate. Now, I am going to show you how to do this multiple ways. The two things we're comparing are costs and ounces. I tell kids, does it make more sense to do cost per ounce or ounce per cost? Which one sounds right? Cost per ounce. Let me tell you a little trick. If it deals with money, the money is always on top. So you're going to set this up as cost over ounces. Personally, all I would do is use a calculator and divide this. Cost per ounce is a division problem. But I'm working with a 6th grader at East, and this is the way his teacher has him doing this. And I'm wondering if this is how you guys did this in younger grades. Did your teacher tell you to divide this by 48 and divide this by 48? And then you end up with $1.56 divided by 48 is this, 0.325, and 48 divided by 48 is 1. So that gives you cost per ounce, which rounds to, well, I have no idea. I would never write it that way. I would say that this is 33 cents per ounce. They rounded it and made it 3.25 cents. Oh, I wrote this wrong. That's a 0. I would say that this is 3 cents per ounce. I would not write it as a decimal, right? I would write it dollars and cents, 2 decimal places. The other way you can do this is this. 156 for 48 ounces. We want to know X for 1 ounce. Set up a proportion. Cost per ounce, cost per ounce. And I like to write a little cheater fraction. We're going to do cost over ounce. Well, how do I solve this? I cross multiply. 48 times X is 48X. 156 times 1 is 156. Divide both sides by 48, which is exactly where we were, and we get the same thing. So you can do it however you want. All right, which brand of soup is cheaper? So we've got Campbell's soup here. It says 4 for $5. And this says they're 12.5 ounces. Is that what it says on your paper? Because I literally cannot read that. Does it say on your paper? Okay, so we're going to go with 12.3 ounces. Okay. And, we're just doing the cost per can. Because that healthy choice doesn't have ounces on it either. Not that I can read. So we're going to do cost per can. Cost per can, which isn't a true unit analysis, because what if one can has 12 ounces and the other one has 15 ounces? It would be best to do cost per ounce, but we don't have the information that we need for that. So for the Campbell's, it's 4 cans for $5. So $5 for 4 cans. What is that? $1.25 per can. And they told you down here that the healthy choice is already $1.32 per can. So which one is cheaper? Campbell's. The only way you can compare them is if you have the same unit rate. Now, either these ounces are unreadable. I would have preferred to go to ounces, which means I would have had to figure out how many ounces of soup we bought and divide by ounces. All right. In 2000, Lance Armstrong completed a 3,630 kilometer Tour de France course in 92.5 hours. Traveling at his average speed, how long would it take Lance to ride 295 kilometers? Find Lance's unit rate. Personally, I would not do it this way. I would set up a proportion. What are the two things we're comparing? And we're gonna do this two ways. We're comparing kilometers and hours. Does it make more sense to do kilometer per hour or hour per kilometer? Which one sounds right? Kilometers per hour. So I'm going to make a cheater fraction. Kilometers per hour. I call that a cheater fraction because it helps me set my proportion up so both sides are the same. So if he went 3,630 kilometers in 92.5 hours, we want to know how long it's going to take him to go 295 kilometers. Well, 295 kilometers in X hours. Didn't I just set up a proportion? So, cross multiply. So, let's do this. 3,630 equal X equals 92.5 times 295 is, wow, 27,287.5. Do not round in the middle of the problem. Please feel free to use calculators this evening. Divide both sides by 3,630. And I end up with 7.52, and that will be hours. And do you notice I looked right up here? X is hours. Now, that is one way to do it. The other way to do it is the way they're working through it. Find Lance's unit rate. Well, Lance's unit rate is going to be 3,630 kilometers for 92.5 hours. If I want to find his unit rate, all I need to do is divide. 3,630 divided by 92.5 gives me approximately 39.24 kilometers per hour. Kilometers per hour is my rate. Write a function that includes this unit rate. Hint, replace the unit rate in distance equals rate times time. So, distance equals rate times time. So, our equation is going to be the distance equals our rate, 39.24 times the time. Now, we want to know how long it took Lance to ride 295 kilometers. So let me ask you a question. Is 295 kilometers distance or time? So let's plug it in the distance spot. So 295 equals 39.24 times the time. Divide both sides by 39.24. And I get T equals 295 divided by 39.24 is 7.52. And that'll be hours. Now, which one was way faster? Set up a proportion. But if they ask you for an equation, you need to find the rate. Question. All right. A Boeing 747 takes 2.5 hours to travel 1,375 miles. Find the average speed. Write a rule to describe the distance it flies as a function of the time it flies. So remember, we're using D equals RT. We are going to use that formula a ton this week. Distance equals rate times time. That is, distance equals rate times time. So, would my unit rate make more sense, miles per hour or hours per mile? Which one sounds right? miles per hour. So 1,375 miles or 2.5 hours. Divide 1,375 divided by 2.5 gives me 550 miles per hour. Make sure when I ask you to find a rate that it has a label on it, because it's not the same thing without the label. All right, write the function. So our function is going to be d equals 552. So that's our rate. Use the function to find out how far a 747 could go in 10 hours. Well, won't that be d equals 550 times 10? So the distance will be 5,500 miles. Use the function to find out how long it would take to travel 2,500 miles. Well, d equals 552. The miles is distance, so 2,500 equals 550t. Divide by 550. 2,500 divided by 550 is 4.5. 4.5, and that will be hours. And I'm rounding. It's not exact. All right. A turtle is moving at a pace of 2 inches per second. By the way, I gave you this gallon man so you can use these for conversions today. Convert this in miles per hour. Do you think that this is realistic? Okay, now I am going to show you what is called the goal post method. Goal post method. So what I'm going to do is this. I'm going to draw a line, and I'm going to start with 2 inches per second. And that's 1 second. Per second means 1 second. So set this up on your paper. You're going to need to have a piece of paper to do this. 2 inches per second. This is what we call unit analysis. We call it the goal post method. Unit analysis. Okay. Now, I need to convert inches into miles and seconds into hours. So, let's worry about the inches first. Okay? We know from our little gallon man sheet that there are 5,280 feet in a mile. Okay? Is this in feet? No, it's in inches. So let's convert it to feet first. Okay? How many inches are in a foot? 12. Now look, these inches are up top. I want to get rid of inches. So I'm going to put 12 inches, 1 foot here. Do you see why I did that? Because this is a division problem. Inches divided by inches are gone. If I have one at the top and the other in the bottom, they cancel out. Now, I am now in feet per second. That's not what we want. We want miles per hour. Still, let's work on the distance. How many feet in a mile? 5,280. It says 5,280 feet per 1 mile. Where do the feet go? Top or bottom? Thinking about the fact that I've got feet in the top here. Yep, 5,280 feet, 1 mile. Feet divided by feet is gone. My top is now miles. I'm good with that. So my label right now is miles per second. That's not what we want. We want miles per hour. Well, you could do this one of 2 ways. How many seconds are in a minute? 60 seconds in a minute. Seconds are down here. So where do I want the seconds in my unit analysis? Yep, so 60 seconds in 1 minute.